this lesson is the beginning of what we will be doing as algebra students, and that is to solve equations. And the first thing you have on your notes is the definition of the word solve. This is also on a big poster in my classroom. It says that to solve means to find all the values that a variable could be that will make an inequality or an equation true. Equations usually have just one answer, something like x equals 3. The only thing it can possibly be is 3. But an inequality has many answers because inequalities use these symbols: greater than, less than, greater than or equal to, and less than or equal to. So an answer to an inequality might be x is greater than 3. So what could be an answer? Well, 4 could be an answer, 5 could be an answer, 102.1 could be an answer. There are many answers when we're solving inequalities. Equations generally only have one answer. In order to solve equations, we will need to use something called inverse operations. Inverse operations are operations that undo each other. So addition undoes what operation? Well, you probably know that addition undoes subtraction, which means that multiplication would undo division. These are called inverse operations, or you could also think of them as opposites. The opposite of addition is subtraction. The opposite of multiplication is division. And when we're solving these equations, we're going to use something called a balance line. And a balance line is a line drawn through the equal sign of an equation. And it reminds us, and I would like you to write this, big capital letters, highlight it, underline it. You're going to hear this pretty much every day in class for the rest of the year. What I do to one side, I must do to the other. You'll hear me say that in class every day. What you do to one side, and I'll pause and I'll wait for you to respond, you must do to the other side. So that's why we draw a balance line. Please remember, the best part about these videos is that you can pause them anytime to go back and fill in information if I'm going too quickly. So here's a little comic that I found pretty funny. The reason I put this comic in because you guys are so smart that when we do this lesson, I'm guessing most of you are going to feel like it's too easy. And it's just because you guys are really good at thinking. You're very good at the things we've done earlier this year, working with positives and negatives. And so it's going to seem really easy, even though it's the beginning of what is going to be some pretty complicated stuff that you'll be doing in algebra. So what I just drew was a balance line. That's it. That's all it looks like. It looks like a line through the equal sign. And I'll be asking you to circle the variable. In this case, that variable is x. And now I have to look at what is with the x that I need to get rid of. And what is with the x that I need to get rid of is a plus 15. Well, what is the inverse of plus 15? Minus 15. And the balance line reminds me, what I do on one side, I must do to the other. So I've done minus 15 on both sides. Now, this is the part where I know some of you can solve these problems in your head, but I'm asking you to show the work properly, which is what I'm showing right now. You're going to then cross these out and put a 0, because 15 and negative 15 are called a zero pair. And that's a vocabulary word that you should know. It's something you'll hear me asking about in class. So now the only thing left on this side is x by itself, which is great. That's what I want. And I need to do 29 take away 15, which happens to be 14. My answer is x equals 14. I'm going to go ahead and try this problem on the other side. I'll put in my balance line. I'm going to circle the variable in this problem. The variable is x. And I have to look at what is with the x that I need to get rid of. I have a negative 23. or a minus 23, and the opposite will be plus 23. That balance line reminds me what I do on one side, I must do to the other. So I'll have to add 23 to that side as well. You're going to make sure that you show that this becomes 0. It is a 0 pair. And all that's left now on this side is x. And I have to look at the other side. I've got different signs, so I'll subtract. 23 take away 9 is 14. And it is positive because the 23 was bigger. Here are a couple more examples. We're going to solve them in the exact same way. These are looking just a little bit different though. This first one, I put in my balance line, I go to circle the variable, and I have to include that sign that's in front of it. That negative sign belongs to the x. There's actually a hidden coefficient there. It's a -1. You guys know I don't write it because I'm lazy, but I do need to remember that that negative sign is attached to my variable. So now I need to get rid of this 21. Well, I know it's a positive 21, even though there's no plus sign there. So in order to get rid of a positive 21, I have to subtract 21. And what I do on one side, I must do to the other. I'm going to show that a positive 21 and a negative 21 give me a 0. That's called a 0 pair. And then I'm going to bring down that negative x. I'll do 35 take away 21, and I've got 14, but I'm not quite done. I can't leave that x negative. I need a positive x, because right now this x isn't by itself. It's got this -1 attached to it. So I want to give you a couple different ways to think about this. One way to think about this is I need the opposite of this. What's the opposite of -x? Positive x. Well, if I did the opposite on one side, I have to do the opposite on the other side. And what's the opposite of 14? -14. So the final answer to this question is x equals -14. I want to show one other way that we could do this problem. It will come up with the same answer, but it's just a different way to think about it. You may use whichever way makes more sense to you. Right now, what is holding those things together is a multiplication. So if I want to get rid of 8 times by -1, I need to divide by -1. And what I do to one side, I do to the other. And this will actually go into the next lesson, which has to do with solving using multiplication and division. -1 over -1 is just 1. So now I have 1x. But you guys know I'm lazy. I'm not going to write 1x. I'm just going to write x. And on the other side, I've got 14 divided by -1. Well, that's -14. No matter what I do, I end up with x equals -14. In this problem, I add my balance line, I circle the variable. In this case, the variable is b. And I need to get rid of a plus 90. Well, the inverse of plus 90 is minus 90. And what I want to do to one side, I must do to the other. And I'm going to show in my work that this becomes 0. Again, that's called a 0 pair. And that leaves me with just b. The b is isolated. That's what I wanted. And on the other side, I've got different signs, because remember this is a positive 17. Different signs, so I subtract. 90 take away 17 is 73. And it is negative because the 90 is bigger. Now, before I go to put a box around this answer, I'm going to ask you to do one final thing, and that is to switch this around so that the variable is on the left and the answer is on the right. And right now, that doesn't seem to make a lot of sense, but we're going to get used to doing that so that when we get to solving inequalities in one of our upcoming lessons, that we're used to writing the variable first because it will be important on inequalities. Now here are some examples that include rational numbers. Remember, rational numbers are fractions and decimals. Of course, they're integers also, but all of my examples so far have been integers. So now we're going to try an example with rational numbers. I do the same thing. I put in my balance line. I circle the variable, which in this case is x. And I look at what is with the x that I need to undo. And I see that I have a plus 2/3. Well, to get rid of a plus 2/3, I must have to minus 2/3. And what I do to one side, I do to the other. I'm going to show again that a plus 2/3 and a minus 2/3 cancel each other out. They become 0. They are a 0 pair. And x equals, well, now this is a fraction subtraction problem, just like you had on your do-nows at the very beginning of the year. You may either solve this using common denominator or using the shortcut method. Either way, I would like you to finish this problem and come up with an answer. That means you actually need to do 4/5 minus 2/3. So you need to finish that problem. On this other side, I'll put in a balance line. I'll circle my variable. And I need to get rid of a 32.1. It's a positive 32.1, which means I know that the inverse or the opposite is to subtract 32.1. And what I do to one side, I have to do to the other. I'm going to show how these cancel each other out to become a 0 pair. And it has left me with y by itself, which is exactly what I wanted. Now on this side, please be careful. You were really good at these problems earlier in the year when we learned how to do this. These are different signs, okay, because this is a positive. Different signs, so I have to subtract. And in order to subtract, I need to do two things. I need to line up the decimals. And I need to make sure that I'm putting the larger number on the top. I'd like you to finish this equation as well. Your answer will have a decimal in it. You'll need to decide if your answer will be positive or negative.